Today we will learn how to find the equation of a tangent of the circle from any point outside the circle. Here we are given a standard circle x squared plus y squared plus 2gx plus 2fy plus c equals 0 with center O minus g minus f and a point P0, x0, y0 lying outside this circle. We need to find the equation of the tangents that are drawn from P0 to this circle. Let's say that the gradient of one tangent is m. Since it passes the point P0, we can show the equation of this tangent as y minus y0 equals m into x minus x0. We can rearrange this into the form ax plus by plus c equals 0 as mx minus y plus y0 minus mx0 equals 0. Let's call this equation 1. The perpendicular distance from the center to the tangent BP0 is equal to the radius of this circle. So the normal distance from O to BP0 is equal to the radius of the circle. We learned that the normal distance can be given as d equals ax0 plus by0 plus c over square root of a squared plus b squared. So that will be m into minus g minus 1 into minus f plus y0 minus mx0 divided by m squared plus 1 whole thing square root. This is equal to square root of g squared plus f squared minus c. So using this equation, we can find the gradient of the tangent. Notice that we have m squared here. So this means that we will get a quadratic equation for m when solving this equation. So this will give us two values for m. By substituting those two values separately into equation 1, we can get the equations of both the tangents from the point P0. To understand this properly, let's answer an example. Here we are given a circle x squared plus y squared minus 4x plus 6y plus 4 equals 0. And we are asked to find the equations of the tangents drawn from the point P0, 5 minus 9. So here g equals minus 2, f equals 3 and c equals 4. Also x0 equals 5 and y0 equals minus 9. So the equation of the tangent can be given as y plus 9 equals m into x minus 5. Now by substituting these values into this formula, we can get m into 2 minus minus 3 plus minus 9 minus m into 5 divided by square root of m squared plus 1 equals 2 squared plus 3 squared minus 4 whole thing square root. The first step we do is square both sides of the equation and move the denominator here. So this will give us minus 3m minus 6 whole thing squared equals 9 into m squared plus 1. So when we open these brackets, we can see here that 9m squared cancels off from both sides and we remain with m equals minus 3 upon 4. So now we substitute this gradient into this equation. So that will be y plus 9 equals minus 3 upon 4 into x minus 5. So finally we get the equation of the tangent as 3x plus 4y plus 21 equals 0. Now for the tip of the day. There are three possible instances for the value of the gradient m. Number 1. Two distinct values for m. This means that there are two gradients, therefore two separate tangents. This also means that the point lies outside the circle. Number 2. One value for m. This means that there is only one gradient, just like our example. This also means that the point lies on the circumference of the circle. Number 3. No value for m. This means that there is no gradient, which means no tangent. This also means that the point lies inside the circle. So that brings us to the end of this video. Comment down below if you have any questions regarding this topic. Until we meet again, take care.